Good afternoon. Let's take a look at the laws of logarithms. So there are a variety of laws. So the first one we have here is the product rule. So log base a x times y. So instead of the multiplication, we can separate it log base a of x plus log base a of y. Then we have our quotient rule. The moment we have division inside the log, we can separate it and say log base a of x minus log base a of y. We have the reciprocal law, but this law is derived from our power rule or the exponential rule. The exponential rule says the following: log base a of x to the power of p. So the moment I raise whatever I have to a power, so for example, let's say I have log base 2 x raised to the power of 3, then I can take this power and I can multiply it to the front. So this will be 3 log base 2 of x. So I took the power and I multiplied it to the front. So because we have this law, I can apply it to my reciprocal law. So 1 over x is the same as x to the power of minus 1. So I take my power minus 1 and I multiply it to the front. That's why we have this law. It is derived from our power rule. Next, the logarithm of 1 is always 0 irrespective of the base. We know that. So remember, I can say log base a of 1 is equal to 0. So 1 is equal to a raised to the power of 0. Anything raised to the power of 0 will always give me 1. That's why this is true. And then the rule that we're going to use the most, and we call that the change of base rule for logarithms. Let's say I have let's make it log base 3 of x. I can rewrite this, and of course I prefer to work with log base 10, so I can change the base to anything. So this base here, b, I can change to anything. It is my choice as long as my base in the numerator and denominator is the same. So I can change this to log base x over log x over log 3. This is much simpler because now I know that my base is 10. Alternatively, I could even have changed this to anything else. For example, I could have changed the base to 4. Log base 4 of x over log base 4 of 3. So my change of base rule says I can change the base if I have split it to my numerator and denominator. So the a goes into my log for my numerator, and the b goes to my log of my denominator. Let's take a look at some examples. Solve the following for x. Log base 2x plus 1. Please remember that this is separate. This plus 1 is not inside my logarithm. Now, the moment I see this 1 here, I see, I want to change this in order to work with this log base 2 of x. The base here is 2. So this 1 can be rewritten as the following. I know that log base 2 of 2 is equal to 1. So I can replace 1 with log base 2 of 2 because log with the same base and this is going to be always 1. Therefore I can rewrite this as log 2x plus log base 2 of 2 is equal to log 4 of x. But now from my product rule, I know that I have the sum of two logs, the base is the same, therefore I can multiply it so that I can write log base 2 times x. So it's my product rule. If there is a sum between two logs, I can get the product of these two if my base is the same. And this is equal to log 4 of x. Now I notice that on the left hand side I have base 2, on the right hand side I have base 4. So I want to change the base. Of course I want to change the base to log base 10. It's the easiest to work with. So I can rewrite this as log 2x. Of course the base is 10. I do not have to write the 10. And log 2 is equal to log x over log 4. Both sides with my change of base rule. Remember, log x, so I take the x, it becomes my numerator. Log 4, it becomes my denominator. Now I can work with this log 4. Log 4 is actually the same as log 2 times 2. How did I get this? because log 2 squared, which is log 4, and I take my power and I multiply it to the front. It's the same as 2 log of 2. Now if I cross multiply here, so let's take whatever I have in my denominator here and I multiply it on the right hand side. Log 2x is equal to, now I'm going to write here log 2 multiplied with log x. I multiplied my denominator on the right hand side and this over 2 log 2. Now log 2 divided by log 2 is 1, so therefore I have log x over 2. I can multiply this 2 on both sides, so then I get 2 log 2x is equal to log of x. But now from my power rule I know that whatever is written in the front, I know that this is going to be the power on the inside. So please do not forget to add brackets. Log 2 of x squared is equal to log of x. And now that I have one term on the left hand side and one term on the right hand side, I can remove my logs. So in other words, I have 4x squared is equal to x. I'm going to take this x to the left hand side, I'm going to subtract x on both sides, so 4x squared minus x is equal to 0. I have a 0. Now I can factor out an x here. This is 4x minus 1 is equal to 0. So therefore I know that x is equal to 0 or x is equal to 1 over 4. But we also know that I cannot have log of 0. Log of 0 doesn't exist. So this solution here does not satisfy my equation. Therefore the only solution that I'm going to work with is x is equal to 1 over 4. This is my only solution. Let's take a look at another example. Solve the following for x. So I have log of something is equal to 1 plus 2 log of x. So again, I have this 1. I can replace this 1. So I see here that my base is 10. For both of these sides, they did not specify the base, or it is not written there, but I know it is log base of 10. So this 1 here, I can write as log 10 of 10. So therefore, on the left hand side, log x squared plus 1 is equal to log 10 of 10 plus log x squared. What I did was I used my power rule. This 2 in front went to my power of the x. Now I notice I can use my product rule. I have the sum of two logarithms. Both of them are in base 10. So therefore, on the right hand side, I can say that this is log 10 times x squared. And on my left hand side, I can just rewrite this log x squared plus 1. Now I have one term on the left hand side and one term on the right hand side. Log of something is equal to log of something. I can remove my logs, so therefore x squared plus 1 is equal to 10x squared. Then I'm going to say I'm going to subtract an x squared on both sides, so this becomes 9x squared. And then if I want to make x squared the subject, it becomes 1 over 9. If I get the square root on both sides, we all know that this should be plus minus 1 over 3 is equal to x. But for logarithms, I cannot work with, so if I have here x is equal to minus 1 over 3 or x is equal to positive 1 over 3, I cannot have a negative logs. So this is not a valid solution, and this is the only solution that will satisfy this equation. So if you have to solve for x, there is only one x value.